morning everyone. Today I would like to show you how to use the linearity property of the Laplace transform to solve the Laplace transform problems. Okay, let me show you some example for linearity. Okay, let's say you have the question that Laplace transform of 3 plus 4t squared. So you can separate into two, okay, equivalent to Laplace transform of 3 plus 4t squared. So you have 4 Laplace transform of t squared. So now Laplace transform of 3, okay, from the table of Laplace transform, you obtain 3 over s. As you know, the Laplace from the table of Laplace transform, you know that A is A over S. If this is the Ft and here is the Fs. Okay, so you obtain 3 over S. Plus with 4, and then this is for t squared. So for the Ft, t power n is equivalent to n factorial over s power n plus 1. So from here we know that the n is 2. So 2 factorial s power 3. So we can solve it like 3 over s plus 8 over s power 3. Okay, 2 factorial means that is 2 times 1. Okay. Another example that I can show you is Laplace transform of t minus 2 square root of 3, power of 3. Okay, let's look at t minus 2 power of 2. What we obtain? T minus 2, so we can factorize it. So you obtain t power of 2 minus 4t plus 4. Okay, if t minus 2 power of 3, this means that you have t minus 2 and then t power of 2 minus 4t plus 4. So if you multiply in, you obtain t power of 3 minus 4t power of 2 plus 4t minus 2t squared plus 8t minus 8. So we obtain t power of 3 minus 6t squared plus 12t minus 8. Okay, so we know that t minus 2 in the bracket power of 3, you obtain this answer. So Laplace transform of t minus 2 power of 3 equivalent to Laplace transform of t power of 3 minus 6 t power of 2 plus 12 t minus 8. So we can separate them. Minus 6 Laplace transform of t power of 2 plus 12 Laplace transform of t minus Laplace transform of 8. Okay, so again, if t power of 3, we're using this formula. So we have s equal to 3, so you have 3 and factorial divided by s power of 4 minus 6. Now t power of 2, the n is 2. 2 factorial over s power of 3 plus 12 1 factorial divided by s power of 2 minus 8 over 3. 8 over s. So equivalent to, so 3 times 2, 3 factorial equal to 3 times 2 times 1, so it's 6. So you have 6 over s power 4 minus 12 over over s power 3 plus 12 s power 2 minus 8 over s. So this is the answer. Okay, we go to the next example. Let's look at the next example. If Laplace transform of the cos square t. Okay, cos square t, we cannot directly solve it, so we need to use identity. Okay, identity cos 2t equal to 2 cos square t minus 1. So if you want the cos square t, so cos square t equal to cos 2t plus 1 divided by 2. So this is the one that we are going to use. So Laplace transform of cos square t equivalent to half of the cos 2t. Okay, we take out the half, okay, 1 over 2, so to here. The Laplace transform of cos 2t plus Laplace transform of 1. So this will be half cos 2t. Okay, based on the table of Laplace transform, cos at equivalent to s over s squared plus a squared. So from here we know that the a is equal to 2. The a is equal to 2. So you have s over s squared plus 2 power of 2 plus 1 over s. Okay. So now we have 1 over 2 s squared plus 4 plus 1 over s. Okay, next look at another example for the sinh. If the Laplace transform of the sinh square 2t. This one we also cannot directly solve it, so we need to use the identity. Again, cos 4t equal to 1 plus 2 sinh square 2t. So if you want to get sinh square 2t, we would have this cos, we rearrange. So cos 4t minus 1 divided by 2. Okay, so Laplace transform of sinh square 2t will be equal to Laplace transform of cos 4t minus 1 divided by 2. Okay, this is from here. This is from here. So equivalent to half of the Laplace transform of cos 4t minus with Laplace transform of 1. This is equivalent to half. Okay, for the cos we do have a cos at equivalent to s over s squared minus a squared. We follow this table of Laplace transform, we can get it s over s squared minus a squared. A is 4, so a squared is 16 minus 1 over s. Okay, that's it. Now we look at a more complicated example, which is we need to use the identity as well. Let's say we have the question like this: 3 cos 3t cos 2t. Okay, we need to use identity again. Cos A cos B equal to the half of the cos A plus B plus cos A minus B. Okay, now you have the cos 3t cos 2t is equivalent to same identity is cos A and cos B. So A is 3t, B is 2t. So we can substitute in here. So Laplace transform of the cos 3t cos 2t is half of the cos 3t plus 2t plus cos 3t minus 2t. So equivalent to 3t plus 2t is 5t plus cos 3t minus 2t is t. So this is we obtain for cos 3t cos 2t. Don't forget the question you have 3. So Laplace transform of 3 cos 3t cos 2t will be 3 over 2. Okay, the 3 we transfer to here, 3. And then Laplace transform of cos 5t, we separate it, and then cos t. Now we have cos 5t. So cos 5t, cos we can obtain s over s squared plus 5 squared. 5 squared is 25. And then s squared plus 1 squared. So this is the answer. You can do this. Okay, next one. Give you the last example. If Laplace transform of the sine 2t plus pi over 3. Again, we need to use the identity sine a plus b equal to sine a cos b plus cos a sine b. Okay, now we have the sin 2t plus 2 pi over 3. So sin 2t plus 2 pi over 3 is equivalent to sine 2t cos 2 pi over 3 plus cos 2t sine 2 pi over 3. So this is equivalent to, okay, cos 2 pi over 3. Okay, make sure you change the degree to radian. So cos 2 pi over 3, you will obtain negative half. So sine 2t negative half plus, okay, sine 2 pi over 3. So sine 2 pi over 3, you will obtain square root of 3 over 2. So Laplace transform of the sine 2t plus 2 pi over 3 equivalent to negative half Laplace transform of sine 2t plus square root 3 over 2 Laplace transform of cos 2t. So this will be equivalent to sine 2t, you obtain the 2s over s squared plus 2 squared. So now we have half of the square root s minus 2. So s squared plus 4. Since denominator is the same, so we just add in. We just add together both. Okay, one more example. Laplace transform of 2 exponent negative t minus 1 plus exponent t. Okay, this one we can separate it into Laplace transform of 2 exponent negative t. Okay, this one can be exponent negative t exponent. So we change to 2 exponent negative t exponent plus with exponent t. So we can take out the 2 exponents since this was is a constant. So 2e exponent negative t. From the table of Laplace transform, we found that the exponent at is equivalent to 1 over s minus a. So similarly to this one, exponent negative t, and then the a is negative 1. So s minus a, so minus is plus. So 1 over s minus a, s minus 1. Okay, that's it. Or if you want to simplify, you can have the s plus a, s plus 1 plus 1 over s minus 1.